Okay.
At Rowan University, the College of Science and Mathematics and School of Health Professions offers students more than 50 academic programs in basic and applied sciences, mathematics, and health professions. We promote a student-centered approach to learning in a research-rich environment.
The professors I've worked with, they're always with you every step of the way. I originally wasn't going to do research on campus, and then my professor for Chem 1 had approached me and asked me if I wanted to work on one of the projects, and I thought it was a really cool and interesting opportunity. I have friends that go to different schools, and they're also in the chemistry programs, and nobody I know really does anything like the research that I'm doing.
Students have small class sizes where they can, in class, get their questions answered and interact with the professor. They have really taken ownership of the research. They're telling you what they should do next. That's when you see that change. That's when you see them grow professionally.
It's helpful that when we do have these labs as classes that we learn how to use the tools that are given to us, like the hydrostatic weighing lab and then also the exercise phys lab. I feel like it makes it so much easier to go out there into the real world and be able to be confident in my skills.
You can't put a price tag on practical skills. And we want to make sure that we're putting out the best, so we make sure that our students know the skills while they're in those lab settings before they go out and even do their internships. We're equipping them with everything they need so that they can be successful in any path that they choose.
Whether it's training the next generation of scientists and healthcare professionals, or providing all students with a foundation in science and mathematics, the work we do today will impact the scientific thinking in our society for generations to come.
Hello, my name is Bridget Malone, and I am the Public Relations and Events Coordinator for our College of Science and Mathematics here at Rowan. And it's my pleasure to also introduce our Assistant Dean, Jennifer Ravelli, who we are excited to have joining us here today.
Hello, everyone. Welcome.
On behalf of the university, I want to extend a very warm welcome to those joining us. Today we have a fantastic panel of faculty, and we also have current and former students who will be giving you a glimpse of what it's like to be a physics student here at Rowan. Before we begin, I have just a few housekeeping items. Our panel will be doing a brief presentation during which all of our guests, I ask you to keep on mute and you have your cameras off, but I strongly encourage you to enter any questions you have into the chat box throughout the session. Then following the presentation, we'll have a question and answer period with the panel. So at this time, it's my pleasure to turn things over to one of our faculty in the Department of Physics and Astronomy here at Rowan, and Dr. Eddie Guerra.
Thank you, Bridget. I'm Eddie Guerra. I'm Associate Professor in Physics and Astronomy. I've been here for quite a while, and I'm very happy to be kind of the master of ceremonies for today's event. I'm also an astronomer by training, so if you want to ask me about what that's all about, you can go ahead and do that. I'm going to hand it over to some of our other panel members. I think our chairperson for the department hopefully can introduce himself.
Hello, I'm Dr. Dave Plaxton. I'm a professor in physics and astronomy and chair, which means aside from doing the teaching and the research, I'm the one who sort of handled all the administrative stuff for the department to keep it running. Ben?
Hi, I'm Ben West. I am a former student in, a former physics student, my bad. I was also an astronomy minor and mathematics minor. So I also did research under Dr. Dave Klassen here and Dr. Eddie Guerra at various points as a student. And I also participated in the physics club, so I can answer questions and such like that. So.
Hello, everyone. My name is Nabil. I'm a recent graduate student of Rowan. I studied physics here as well, and I'm currently in my master's studying mechanical engineering. But I think that I got a real good foundation of understanding science and physics from Rowan, and I think that I can answer any questions if anybody has about my experience here at Rowan.
Hi, I'm Liliana. I transferred here in 2019, and I'm enrolled in the 4+1 program for my bachelor's degree in physics and my master's degree in STEM education.
Well, I think that's all our panelists. I'd like to thank them for introducing themselves. I think right now we'll start by talking about our academic programs, and hopefully our panelists will interject when they have some good comments to make. You can see nice physics equations on the board, which everyone in this panel probably has experienced one way or the other in their careers. Let's go ahead and start talking about our academic programs. We have three major degree programs. One is a Bachelor of Science in Physics. The other one's a Bachelor of Arts in Physics. The main difference is in the Bachelor of Arts, there's a bit more flexibility to double major or combine it with other programs. Often it's paired with things such as education's a traditional one. We've had students combine the BA in physics with things as diverse as writing arts and gone on to very successful careers in communications and science communications. So besides the BS and the BA, we also have the BS in biophysics, which we'll talk a little bit more in detail in a second. A very, very, I think very, very important program that separates our university from a lot of other universities here in the region and nationally. We also have a minor in astronomy, and that's what we often encourage students interested in astronomy and astrophysics to do, is pursue the minor while pursuing a physics major. Many of us who go on to do work in astronomy are basically physics degrees or equivalent, and that's a much more, I guess, balanced academic background, while you still can specialize. Also, minoring in astronomy just for the sake of it being an interest and something very edifying is something we also encourage our students to do. We also have 2 certificates of undergraduate studies. These are in health physics and photonics, particularly some areas that are strengths for Rowan University that our physics program can offer you benefits. And of course, there's some cross-disciplinary involvement across departments. I mentioned, again, students majoring, double majoring in things in other programs. I don't know if anyone has anything to add to that in the panel. Otherwise, you can move to the next slide. Maybe we could have Dr. Klassen.
Yeah, so the biophysics degree is relatively new at Rowan. Well, relatively new. It's been around for about 4 or 5 years now. So we've actually graduated students in the program. It's fairly, I was going to say fairly unique, but I hate that phrase. There are very few undergraduate bachelor's degrees in biophysics, and we're one of them. You can see here Professor Nucci, who's sort of the director of our biophysics program. Biophysics is a really interesting area of physics that right now is where a lot of the research money is going. So it's a really up and coming field. You get to learn a lot of the biology and apply physics techniques to understanding it. Biology has come a long way in how it studies things. The one really interesting thing about our biophysics program is it is designed specifically to give a student enough background to either go into a graduate program in biophysics or directly into med school. You might wonder, well, why not just get a biology degree and go into med school? Well, because I think the training you get as a biophysicist gives you much more analytical capability and power. It's what we specialize in physics. And I guess the last question is about whether or not you can change your mind later. The first 2 years of pretty much all 3 of our degree programs are effectively identical. So you really don't have to make up your mind until the end of year 2.
Very good. Thank you, David. In addition, we also have graduate and accelerated degree programs in combination with our bachelor's program. And one of the, again, combinations here include going on to a master's in data analytics, and in this case, in an accelerated program, which is a 4+1. So you get to start your graduate studies before basically in your 4th year. And beyond that, we also have things with the Masters of Science in Cell and Molecular Biology at the graduate school at the Rowan School of Osteopathic Medicine in Stratford, which is part of our university system. Also, we do have a 4+1 for physics, both the BA and the BS, and a master's in STEM education. And I think Lily, you can comment a bit about that.
Absolutely. So I am involved in that program. I absolutely love my experience and that you get so much, you end up with a whole degree in physics, your entire bachelor's degree, and it's very flexible in that you're able to choose what kind of classes you want to specialize in. And then you complete an entire master's degree in just an extra year. What's fortunate about that is that you end up getting half of your master's degree for the price of a year of a bachelor's degree. So that really helped me because I don't have too much money to be spending on getting a master's degree. So I might not have been able to get a master's degree otherwise if it weren't for this program.
Thank you, Lily. On top of that, we also have 3+4 programs with our medical schools. And Rowan has the unique, I wouldn't say quite unique, there is one other university actually in the country that has this distinction of having both a allopathic and osteopathic medical schools. So you could combine your BS in physics to get a medical degree either at Cooper Medical School of Rowan University or the Rowan School of Osteopathic Medicine. And again, the deadline's noted there. And one thing that's very unique, very important about our program, one of our strengths at Rowan is the PhD in Material Science and Engineering, which is a cross-disciplinary PhD program that really accentuates our strengths in engineering, chemistry, and physics, and a lot of the overlapping interests in materials.
And while this program is really new, we will have our first PhD graduate, all going well, at the end of this year. So we'll have granted our first PhD in material science and engineering.
Wow. Yeah, it's a lot of new important stuff here.
I think that's him right there in the picture.
That's that's what to say. I recognize him. Pride and joy of our departments. I think we can go on to the next slide. So anyway, moving on, there are highlights again of our department. And one is that we do have advising with professional advisors. Also, if you end up getting involved in things like medical school or health professions, we have an Office of Health Professions, which provides advising. We also have faculty mentorship, and that takes in both kind of many different forms. And part of it is because of our student to faculty ratio. We have a large enough physics department to have a lot of opportunities for students and a lot of students to do interesting things with. But we aren't too gargantuan or colossal that we can't have the student-to-faculty ratio in a lot of our classes for our majors, 16 to 30 students. As an example, I'm teaching a class this semester, a 200 level class in astrophysics with 16 students. And that is not atypical. But again, we could offer that course on a regular basis and offer these really value-added opportunities. But in this case, I'm really getting to know the students quite well in 1 week, and they've been quite helpful in terms of my clumsiness with Zoom. So this rapport that can develop with our students really lends itself to abilities for our faculty to mentor students professionally, whether they want to go in research or into some more applied area or into industry. Again, we have a lot of these flexible opportunities with electives, minors, and certificates. And I think we also have, again, a very dedicated attitude in our department about innovative ways of approaching pedagogy and experiential learning, and also the fact that our research opportunities themselves are a kind of learning that is beyond the book, and the ability to use equipment, like if you want to use a telescope on top of Science Hall, that's a ready opportunity both within a class or in a research opportunity. Moving on, I guess there's more in the slides here, right? Again, I mentioned our size of our major, 170 majors. We do graduate the second most degrees in physics degrees in New Jersey. And again, like I said, it's a large enough department that there's a diversity of students, but it's not so large like other major programs that I can mention and other universities that even here, that we don't get to know our students. Our cohorts that we graduate, we really do get to know them very well. It's a perfect size. It's just right size department, as I say. We're also the home attached, the academic home rather, of the Edelman Planetarium. Rick and Jean Edelman, of course, are a couple of our alumni who have been generous in donating not just only to our program here, but other programs at the university, including the Fossil Park and the College of Communications. But the Edelman gift has really enhanced our ability to share the excitement of astronomy in the region for kids of all ages, including people older than I am. But more importantly, it's also enhanced our observatory and gives opportunities for our students to do some interesting things right here on campus in our observatory. We also have some amazing teaching labs with a ton of equipment and a ton of cool stuff. Like I said, I have a very inexpensive piece here, but we do have students get their hands on some nice equipment in classes like modern physics and in astronomy and other stuff, but also state-of-the-art research laboratories and advanced instrumentation, scanning electron microscope, thin film sputtering, X-ray diffraction, to name a few. I think we have a new visitor here. Welcome.
I would like to
David,
say
if you want to
that
expand on our research equipment and the holdings.
yeah, so it's we are a really fortunate in our area that we have had our researchers build up these research labs over the past couple decades. That we have instrumentation that's approaching about $5 million of holdings, and we have instruments that you would not expect to see at an institute our size and a program our size. We have about 12 full-time teaching and research faculty that, a place like us, I mean, the fact that we have this just is a testament to the amount of research and the quality of research going on.
I don't know if any of the alumni and current students have any comments on the access to instrumentation.
Sure, yeah, I've had access to the scanning electron microscope. Very, very nice piece of machinery. I've never worked with anything like that before, and I had to be real careful because it was, I believe we have two of them, and I was using the newer one, but very nice. I was able to actually take pictures at very high magnification, and allows you to see things at the smallest scale. So it's very nice, and I've actually been working with the thin films sputtering recently because I work in engineering now, and I do research under Dr. Way and Dr. Hedinger, and that requires some of that. So it's really nice to get to work with things like that because these are also machines that are used in the real world. So once you graduate, you're able to transfer these skills to the real world real easily by using these things.
Thank you, Nabil.
Just to add as well, for the equipment, I've gotten to use the telescope that we have in our observatory. And although it's not the normal physics equipment, that is definitely astronomy, and this is the physics and astronomy department. So getting, as a student, to be able to use a telescope that would be used for research, get to start it up, set it up, fully operate it, basically, that's something that I don't think a whole lot of undergraduate students would really get an opportunity to do at most universities.
Yeah, I mean, we have, in this case, with our microscopy, ability to go to the smallest scales. And I know Ben's projects include galaxies that were over 500 million light years away. So we do cover the whole range of possibilities here in our department. And one comment is, I know some alumni have told me that they've gone on to graduate programs and their fellow graduate students haven't even had access or even aren't even able to work with equipment that they've already trained on here at Rowan. Some anecdotes that I'm hearing. And that's something that I feel is, while we do have graduate programs, we still have undergraduates as a very important component of our research enterprise. We can move on to the next slide. And of course, our student community, which you've gotten to meet some of these folks, including the gentleman here with the with the wonderful telescope there. I should make the comment, that's a very special telescope. It's designed to watch the sun. You can't observe the sun unless you have that specific equipment, so don't try that at home, please. But again, as Ben was saying, he has gotten his hands on that kind of equipment and knows how to use it safely. In case in point, he's showing the wonders of our sun and the sunspots to these future scientists here, these young ladies who are joining us for a community event as a part of our community outreach. Department research. Let's talk about that. Oh, yeah. Oh, we're going back.
I'm sorry, Eddie. Did you have anything else you wanted to add to this?
I was going to say really quickly again, our Society of Physics students, so award-winning department club opportunity. I don't know if any of the students can comment on that because and alums who've worked with that, if they have anything to add about Physics Club. Society of Physics students?
I can't say anything about the Society of Physics students, but I can say for the Physics Club, it's an excellent resource that allows many physics students to come together, have a room in which they can often work on problems together or discuss, bounce ideas off each other, etc. And also the Physics Club will occasionally do outreach events to nearby schools or other areas to teach physics concepts using some equipment from the physics lab, some equipment you might use in the classroom, or some equipment that we just have on hand that can be used just to teach other people about physics. And it's an excellent experience, not just for helping yourself get a better understanding of a whole bunch of these concepts, but also getting experience, say, teaching people some of these concepts. So that also applies with astronomy. We can bring out telescopes, and we do about monthly open house events for members of the public to come and see stuff through the telescopes, learn about space, and for people to get experience operating these telescopes. That's what this event here right now was.
Yeah, I think one thing I'd also add to what Ben just said about the Astronomy and Physics Club is that they also partially sponsor students to go to events like conferences that happen, major conferences. And I think that the Society of Physics students had a recent event that we helped put on. And I'm not sure if it entirely went through, but we were helping them and make that process happen. So we definitely have a lot of partnership with them, and we do try to go to conferences and send our students to conferences. So it is a great opportunity to get involved.
Thank you. Thank you. Like I said, it's an award-winning physics club. It's for quite a few years. Grew. It's one of the pride and joys of our department. I think now we can transition to our next slide and talk about research some more. Departmental level research and what we have going on here.
There's the scanning electron microscope, just in case you wanted to know what one looked like.
Oh, that's the new one, right? It's nice when we can say the new one, like, yeah, because there's the other one. That's, again, kind of an embarrassment and a good kind of situation to have. So let's see what our research areas are, and I can talk about them really briefly. Again, we have astronomy and planetary science, and you see, actually, I guess the two of us here, Dr. Klassen and me, are astronomy and planetary science. And we can go on and on about about our research. We have a long history of engaging undergraduates and training them. And some of them have gone on the graduate programs. I think one of our recent ones, Sarah Kessler, she's in the PhD program at the Ohio State University in astronomy, among other outcomes for our students. So we also have atomic, molecular, and optical physics. As we mentioned earlier, the biophysics, we have biomedical physics as an area of research. Condensed matter, which spans the thin films to other things that are occurring in our research space. We have faculty do particle physics, and of course, physics research, physics education research. We have one of our faculty, Dr. Smith, who has brought in some pretty large grants to work on that area of research. And obviously that ties into our history as a college, university rather, that's had a tradition of teaching teachers and creating future physics teachers. It's something we take very seriously. I don't know, David, if you wanted to dive into.
Just to try to drop a couple projects that are going on. We have a researcher in the biomedical area who's working with insect silks to make patches for the internal of the body, so that when you get patched up, if somebody has an injury, you get patched up, closed up, it just dissolves away. It's biocompatible, and they don't have to cut you back open to fix things. And in the area of condensed matter, Dr. Laughlin there, who's playing with our X-ray diffraction machine there, has a project where he's looking at applying techniques to make bridges better, as well as something called magnetic rubber.
Oh yeah, now I start thinking about. Of course, we have a lot of our faculty have a very strong track record of funding. Dr. Nathaniel Nucci getting large NSF grants and things like that. So this is what that funding does. It allows the opportunity for our faculty to hire students in research positions and do a lot more things and engage, and with paid opportunities. Students having an opportunity to do research. Which I think is again a nice opportunity to make money while you're basically training. I think that's covered all the bases. I guess maybe the students might hopefully will have some questions, or our guests rather, and then we can dive down on that. But I think we can move to the next slide, which I think talks about the importance of undergraduate research. Like I mentioned earlier, we have these budding graduate programs, and we're going to continue to grow that strategically. But we have a large focus on the fact that we are training undergraduates, and the undergraduates are a big part of our research enterprise. Our students in the Bachelor of Science programs have to do are required to do 1 year of research with faculty, and that's part of a physics research methods course. But there are other opportunities to engage in research, and one of them is a college-wide summer research program, which hopefully we'll be able to do a version of this summer, knock on wood, with our constraints with COVID straining our system here. But this opportunity and opportunities at other universities for students to be involved with paid research opportunities are the two kind of main ways our students get involved in research. But there are additional ways, whether for credit or for pay, for students to get involved in research. So think of the BS requirement. That's a minimum. There's way more opportunities, especially if someone wants to come in early. They have the ability. There might be some opportunities which can present themselves. And we do think it's important research because it's beyond the classroom. But why it's good for the undergraduate is the ability to learn these skills, which are part of our physics research methods course, is the presentation. In fact, that's an interesting part of the grading process that David and I, Dr. Klassen and I know. That's something we take seriously. In fact, very challenging in the time of COVID too, because normally these would be in-person presentations, but we've had to now adapt to the real world that is now. And on top of that, of course, is the faculty mentorship. I've had the opportunity in physics research methods to take students to the observatory rather, and the mentorship goes just beyond the equipment. It goes beyond, you have a chance to talk to students and understand what their concerns are, and it creates a very different relationship than sitting in a classroom, I think, although that can create a bond and mentorship too. And of course, that laboratory equipment experience. I mean, it's the fun part. I mean, a lot of us love toys. I like handling equipment. I enjoy visiting when I go see my other faculty colleagues' labs and seeing students, working on equipment. I mean, even the students who used to work with me did an astronomy project. They're off doing a biophysics project. If I had one student, Kara Moss, and I remember she did astronomy project, and she went and worked for Nathaniel Nucci and did biophysics. And she got so much out of both experiences, and some of that stuff carried over actually. Again, going from the big to the small is what our department offers. And of course, we have opportunity for workshops. We give advising workshops, seminars, and things like that. Like I said, also paid positions and stipends are a big part of this. I don't know if the students, students, or anyone else want to add something to this slide. Any comments?
I would like to say, and maybe somebody could jump in on this, but I think one of the other things that really helps with the research is it really helps you build relationships with scientists, so that when you move forward in your career, you have those touchbacks. When you need letters of recommendation, when you need, just somebody to talk to again later. When if you want to bounce ideas off, you can always come back and chat with us. Things like that. So you build those relationships early instead of waiting to be in graduate school.
And I've had students ask for letters of recommendation for graduate students, been references for jobs, and even graduate studies in things like, other non-science programs, right? They've gone and do that things, and I've been asked to do letters, but I can write a letter which has a lot of commentary beyond what they did in the classroom. It makes for a letter with a lot more content, and one that's going to stand out when you go up for, I guess, when you have a reference or a letter of rec. I don't know if the rest of the panel.
Do we have any students that wanted to add to this?
So I will, or Nabil, do you want to go first, or?
Sure, Ben. Yeah. So I also partake in SERP, just like Ben as well. And my first opportunity at research was actually at SERP, and I got to work under Dr. Dobbins, who spoke earlier in the video. And I got the chance to not just do research here at Rowan. She actually had us go out to national labs in the United States, such as Argonne National Laboratory. where I got to work with the photon source there, the advanced photon source, and capture some USAX data, some ultra small angle X-ray scattering data, and to study my samples that I was specifically making. And another lab that I got to visit was the Louisiana State University's Center for Small Advanced Microstructures and Devices. So besides just, being able to do research at Rowan, I got to also visit other labs and visit other scientists where I made connections there. And, that was all just through Rowan, this program, and Dr. Dobbins. So like you guys were saying, there are multiple ways to network and just actually be able to use that to your advantage later on. Great experience overall.
So I would like to also add that the research that I did with Dr. David Klassen here, and I was doing astronomy research, which meant I was also programming, and I was having to think about a whole bunch of stuff, a whole bunch of mathematics. And so I got experience in more than just physics, things that are related, but which I wouldn't necessarily, well, math, of course, in this, but some things which I wouldn't necessarily learn directly in some of my classes. And those are other experiences that can definitely be immensely valuable, which you might not get just on their own and which you might get in research.
Thank you. So this leads to career pathways. One of the questions that our panel could probably answer some, right? About what we can do. So let's go ahead and see what do our physics graduates do? One of the obvious places is a graduate school in physics and astronomy. I already mentioned one of our alums already. But also we have a lot of students that go off to applied physics and related fields in graduate school, like engineering. So again, we have another example of that in our panel. Engineering graduate school, again, that's our other colleague here. And then we do have a tradition of trying to create high school teachers, and we've had a few folks go on to teaching and jobs in industry. And again, some of the companies are listed there: Thor Labs, Emin Optics, Sony Music, government laboratories, and medical school. If I could just thinking of the handful that I know that went to medical school, including one of our students who went to Rowan SOM, osteopathic medical school. And I will add also, we've had a handful go to law school on top of all that too. So David, I don't know if there's anything about that you wanted to add.
Edmund has been a wonderful employer of Rowan grads. Basically what happens, and what's really nice, is when we get a grad into a place, that place gets to know Rowan better, and they get to understand what what a Rowan student does, and that actually creates more opportunity. In fact, we have a budding co-op with Edmund now. It's gone well. COVID got in the way for this year, but we've had it go on, and we're going to work on it to get it going again for next year, where you take a semester and you go work full time for Edmund, and they get to know you really well.
I would say our students that have gone to these companies, clearly they know who we are, and they are coming back for more, which is the kind of the ultimate sign of approval there. But
I think we've got several at Lockheed as well. So
that's right. And Thor Labs, I think we've, right. Yeah, there it is right there. Thor Labs is there. I saw the little emblem there. I guess we can move to the next slide since I want to keep us moving here. This is it. The best part where we get to answer the questions that our guests have for us. So please don't be shy.
Yeah, so panelists, I'm going to ask you to turn on your cameras and unmute yourself. And I'm going to stop sharing my screen so that everyone can see us. Hello, everybody. Let me get started here. Okay, so I just have to say one thing first. This group has been very tame during this presentation, but those of us that know them better know that they are so much fun, and it is a really close-knit group. And just to illustrate that, Ben, I need to know what is behind you on your virtual screen there.
This is a picture of Mars, believe it or not, which is making Klassen here very happy. This is a picture of Mars taken by a spacecraft called the Mars Reconnaissance Orbiter. using an incredibly high resolution camera it's got on board. And what we're looking at is a sand dune, basically, on the surface of Mars. And we have trails left by dust devils, which are, in a sense, kind of like little tornadoes in the dust on the surface of Mars. So it's cool. It's a dynamic thing on Mars that you wouldn't necessarily expect.
Okay, and Dr. Garrett, what do you have? What's your toy in the background?
You are muted.
I just realized that this is a celestial sphere. It's a tool that we use for our introductory courses, including observational astronomy. It's a model of the universe with the Earth at the center and all the stars painted on the sphere. And this was the original model of the universe that the ancient Greeks had, but it also makes a great map and for directions in the universe. We still teach it because it allows us to put coordinate systems and things like that. And it's just a fun thing I carry around everywhere I go, literally. Try to teach how the Earth rotates and how the sky moves because of it.
Okay, thanks, guys. Lily, I wanted to talk to you. So I know you are a physics major and you're also in the STEM education, and I am just thrilled to hear that because I know we need lots of female teachers so that our female high school students enjoy physics and they see females in the classroom and have that mentorship opportunity. So could you tell us a little bit more about why you chose that field and what it's like, the program is like at Rowan?
Absolutely. So I didn't know I wanted to be a teacher until I had the opportunity to tutor within the department, and that really sold me. That was, this is what I want to do. I love working with the students. So that's what I decided to do. So the first 3 years of the 4+1 program is mainly physics. I get to specialize in something. I was a learning assistant here. I worked towards a math minor. I did a little bit of research. So I really got to kind of check everything out in the department. And so I'm currently in my 4th year, which is that's the end of the bachelor's degree and the beginning of the master's degree, which sounds like it would be a little crazy, but it's not. It's actually so much fun because now I get to work with both things I really love to do, the physics and the education side of it. So the 5th year is the student teaching year. So I actually go into a high school and student teach in an actual classroom, work on my portfolio, and then get my certification at the end of the year. So really the program is a whole physics experience and a whole education experience. It's a really well-rounded, fun program, and I'm very confident in both my ability in scientific physics knowledge and my ability to teach. It's a fantastic opportunity. I love my students.
Thank you so much. I can already tell you're going to be a fantastic teacher. You're so well spoken. Jen, do you want to check out the chat box and see if there's anything in there? And I want to make sure everybody that's joining us has the opportunity to ask questions. So please go ahead and enter them in the chat box.
Sure, we do have a question. We have a student asked if they could have more details about the Certificate of Health Physics and Photonics.
Okay. I think that I have some more information I can share, but you guys go ahead and start talking about it while I navigate to that.
So as the chair, I was sort of helped steer along these certificates. So a certificate, what differentiates it from, say, a minor is something you get along the way with your degree. A certificate can be done that way, but it also is something that you can do as a non-matriculated student. So let's say you graduate and you say, oh, wait, I want some more education. You can come back and fill in and get these. A certificate is built off of 4 courses, and when you're done, you get a certificate. And the 2 areas we have our certificates in are health physics and photonics. Health physics, both of them are areas of great need in industry. Both areas are, as I've been told by people who helped build these with us from industry, is aging out. That is, the people who started these programs in industry are retiring, and there aren't people behind them to fill those positions. So they are in desperate need. Health physics is primarily an area where you would be the person that looks after what the doctors are trying to do when it comes to radiation therapies. making sure that the patients don't get too much radiation, that the radiation goes to the right places, making sure that all the radiation instruments meet regulation, things like that. And so we have a whole bunch. There's an initial biophysics course you take, and then 3 radiation-based physics and instrumentation courses.
Dr. Klassen, would you be able to graduate with a bachelor's and this certificate and go right into a job, or would you have to do a more
pretty much
work?
you would go straight into a job. You don't have to have a master's degree to get these jobs. These would be like the radiation tech positions at hospitals. You can then, while you're on the job, work towards master's degrees, and a lot of these industries will actually pay for that. The person who helped build this with us, this certificate, actually was one of our former graduates who had to do all this on his own. And now he's helping us come back and build the certificate to make it easier for students to be ready to jump right into those positions.
That's great.
The same is true of our photonics. That's one of those areas that
Hold on, let me get to that slide for you. There we go.
Yeah, photonics is a word that people don't really understand, but think of it as this: photonics is electronics, but with light instead of electricity. Okay? And so it's the foundation of a lot of modern communications, and also just it involves a lot of just standard optical design and instrumentation building with optics, laser-based communication, things like that. And again, the people who built this industry are retiring, and there's not the pipeline isn't full. And so again, another one of our former graduates who did all this on his own has come back to help us build this certificate so that students are ready to jump right into these jobs as soon as they come out with this degree program. If you are in the physics degree with the BS, you can get a photonics concentration, which gives you the same education, and you jump right up. So you get that extra little bit on your transcript saying, "I'm ready for these jobs." And these are high-paying jobs. These are really good jobs. And so he's been helping us do this, and it's been great.
Okay, thanks.
So we have another question. Is there anything that a student should or could be doing in high school that could further prepare them for a course or like the program in photonics, besides taking high school physics and astronomy courses?
At the high school level, I would just say load up on all the math and physics you can. The photonics kicks in about the sophomore to junior year when you start specializing. So you really need to get that foundation of the intro-level physics, the modern physics, and then you start taking things like optics and light. You start taking advanced electricity and magnetism to understand how light interacts with things, because that's all laser is light. So it really takes off in the junior year in the degree program. So just get that foundation as strong as possible, and I think that's the best preparation you can get.
Yeah. What's nice about things like the minor and the certificates, that's something as you get your feet underneath you after that first year, you can start diving into. The key is that first year. And I will say this over and over again: math is our language, and math.
and while you're in your high school physics, if this is the way you want to go, pay particular attention to your ray optics and even your wave optics. I can't remember if high school touches much on wave optics. Get that ray optics down.
The ray optics, gosh, yeah.
Don't get too technical. We don't want to scare anyone.
And so while you talked a little bit about careers for those 2 jobs, what other typical careers can physics majors consider?
Oh, I got a screen for that too. So go ahead and get started.
Excellent.
And I'll get that.
I'm gonna give my favorite quote, and I can never remember who did this. I was gonna look it up, but 30 years ago, if you wanted to be generally educated for the world, you got a humanities degree, and then you could go off into any area of business and excel. In a technical society, sort of the foundation is physics, and so we really go everywhere. Oh, thank you for this. Yeah. So these data were compiled by the American Institute of Physics. They do this every year. Well, not every year. I think this was 2014 was the last time they did this, and they come around with the stats. So this first slide is showing you that if you get a physics degree and you go into industry, what is your job title or where do you go? And you can see that over a third go into jobs that call themselves engineering of some kind. Businesses and technical industries hire both engineers and physicists, but they do it for two different reasons. They hire the physicist because the physicist thinks outside the box. The physicist is going to solve the problem for them. The engineer is, I'm going to build it in such a way that it's actually like can be afforded, that somebody can afford it, right? The physicist is way out here thinking, how can I fix this problem? Finds the solution, and then the engineer turns it into something that they can sell every day. Other areas are in computer information systems, especially in research. As Ben mentioned, he did a lot of programming. He learned a lot of programming that you don't necessarily get in any other, in just general coursework. And so picking up these side skills lets you move into these kinds of areas. And then other non-STEM jobs. I think we mentioned things like going into law, going into medicine. That might be considered other STEM. Going into journalism. We've had kids go into journalism when they graduate. So it really, if it involves technology and science, a good physics background prepares you for moving in that direction. It gives you these skills and abilities to teach yourself the details necessary to do those jobs.
So they're self-learners, really, and they
problem solving. I mean,
problem
just
solving.
Thinking through problems is what physics is all about, and business needs that, and all these areas need people like that.
I think I have a slide, if I can navigate to it, on salaries too. Do you want to touch on that too? If I can get there without messing everything up.
I love that.
Oh, I did mess it up. There we go.
So again, AIP data, collecting all this, and all the other institutes do this too, so they get the data for the other majors. Yeah, we're sort of, if you get a computer science degree and you're doing all that cryptography stuff, yeah, fine. Aerospace engineering, very narrow area and very narrow field. But you can see physics actually, well, there's a large range, mainly because there are so many jobs that physicists go into. That's why that area is so broad. But you can see that these are sort of typical median pay for starting out as with just a bachelor's degree. So you're looking at about the 70K level, up at the upper end. Depending on what you end up doing, if you're going into graduate school, you're going to be down near at the 30K end, or depending on the job you choose. But it's got a huge range because of the vast types of jobs you can do. But we're pretty much near the top of this scale, right? Those chemists, man, I don't know. You really need to get a master's degree if you're going to make money in chemistry.
And I think this graph also reinforces the other graph where we see that the skills we use transfer over to things like engineering and computer science. We look at the other disciplines that are overlapping the most with the red. On the high end, it's the computer science, and on the low end, on the middle, the high to middle, most of the range rather, it's math and
engineering. Yeah.
Okay, I'm going to stop sharing the screen so we can see everybody again. I want to pick on some students because we have students on the program here today. So I think it's always nice for them to hear from other students. Let's see here. Okay, this is a softball. You guys are obviously very bright. When you're looking for colleges, I'm sure you looked at different curriculum and, wanted to make sure you were in the right place. So why did you choose Rowan? And for those, well, Lily, you're almost done too. So you guys are almost done or have done, or you're in grad school or you're starting your new careers. So looking back, what was your favorite thing about being a Rowan student? And it doesn't have to be physics related. Should I pick on someone?
I can jump in here. So I chose Rowan because I transferred from a community college, and Rowan really accepted all the credits that needed to be accepted for that. It was a seamless transition for me. And just the program is just fantastic. It's on par with more expensive universities, so you really get your bang for your buck here. You really do. It's close to home for me. I love the community, the mentorship. I went on a tour, and just the welcoming environment really sold me the minute I walked onto campus and even into our science building, and getting to know all the people who became my mentors and my wonderful, absolutely wonderful instructors. Really, it's a fantastic community to get involved with, and that's, I think, my favorite thing about being in the physics department is the wonderful friends that I've made and the support. Such a supportive community that I've been able to be a part of at here is just invaluable to me. I certainly wouldn't be the person I am today without the people, the mentors, my peers that I've gotten to know here at the university.
Thank you. Did anyone else want to share anything?
So I actually initially chose Rowan. I believe I was between Rutgers and Rowan, and what really won me over was the class size, believe it or not. Because I kind of
I
realized I
believe
didn't
it.
want to sit at the back of a lecture hall all day for 4 years. And having the smaller class sizes also allowed me to actually get to know professors, as opposed to potentially even just being stuck behind the TAs, talking to TAs or something, as opposed to even getting to talk to the professors in the first place. And I think that getting to talk to, meet, and know the professors was invaluable to my time as a student. On top of that, as Liana said, the community, at least in the physics department, I can't speak for other departments, but the physics department, the students are a pretty tightly knit community. I'd say most of the friends I made as a student were largely in the physics department, because you just get to know each other all pretty well, work with each other all the time. You get to know people, and I think the community is invaluable, and I think it's pretty good.
Great, thanks. Nabil, do you want to add?
Sure, yeah. So I think I'll be honest here. My transition from high school to college was um, kind of unique because I was an athlete in high school. I played basketball and volleyball, but I was also just like that person in my friend group that was also kind of a nerd, really liked learning, and I embraced it. So I think that for me, my senior year of high school, I was like, okay, I need to. So I wasn't really financially stable at the moment to, go to college and pay for school. So I know that I needed a way to get there. So I tried to get a scholarship through a sport or through education. So that's when I really try to kick in with classes. So I think it's like Dr. Klassen and Dr. Guerra was saying, you should definitely take up all your math courses and your science courses, because your scholarships will come from, I think, mostly those kinds of areas. So that's what I try to do. And I applied to, believe it or not, I applied to NGIT because I was going for engineering, right? And I think I applied to Ramapo College and Montclair. And then one of the teachers I had was just like, oh, you're looking for engineering? Apply to Rowan. She just simply threw the name out there, and I had no idea what Rowan was because I'm all the way in North Jersey. So she threw the name out there. I applied, and the only school that accepted me was Rowan University. So all the other schools kind of didn't respond to me, or one of them just kind of rejected me and said, you should go to community college because we don't think you have the foundational skills that you need for the program. So, it discouraged me. But Rowan, on the other hand, kind of said, we can let you in here, and, we'll let you start off in this program. And then if you want, you can definitely transition. So along the way, I took electricity and magnetism, an introductory course with Dr. Nathaniel Nucci. And that class was the one that kind of caught my attention. And that's the one that really basically opened up my eyes to physics, because before that I took intro to mechanics, but that didn't really talk about, electrons and protons, kind of like, how they move. And when they move, they create a magnetic field or something like that. And then you're like, why is that even happening in the first place? And then all these kind of questions arise. And that's where I started to get really fascinated with it. So that was my whole transition into it. And now I graduated, and now I'm in engineering. So I think Rowan was the best option for me. I think I got lucky.
I think that is a wonderful story, and I really appreciate you sharing that. I hear some of those similar stories from some of the best students that we have on campus. I'm not surprised that Dr. Nucci, pulled you in. He's very talented and he loves his students. I also really wanted to touch base on something that Lily talked about, which was being a transfer student, and that you said that it was a seamless process for you. And I think that that's really important for some of the students that we have at the local community colleges. They may not think that being a physics major and going on to grad school is something that is feasible for them. So Dr. Klassen and Dr. Garrett, can you talk a little bit more about how we make the process easy for transfer students?
I mean, Dave, I mean, you want to?
Yeah, so one of my jobs as chair is handling all of the transfer agreements and assessing transfer courses for what they come in at. And I look at my job as how can I make it the easiest possible for the students as they come in. We have, I think, Lily, you went to RCSJ, right? Right. So we have very strong ties with Rowan College of South Jersey and the other Rowan College.
CBC or Burlington.
RCBC. Burlington. Okay. But we also, I mean, we have we try very hard to make that transition as easy as possible, so that the courses that you bring in will transfer into the program. And what makes it a little easier is that, intro physics is intro physics almost the world round. There are some places that do weird things and they annoy me, but for the most part, it's pretty easy. So transferring into the physics program, physics is a fairly linear program. You have to take course A to get to course B to get to course C, and then it opens up. But as long as you get course A and B at the community college, you're good. And so we bring you in and we can make that work. And I think we're really good at trying to find those opportunities to make that transition easier.
Okay, thank you so much for that. And unfortunately, we're at the end of our time, and I had some other things that I wanted to touch on, but I'm going to share a contact page here so that if people have additional questions or there's something that we didn't get to, let me just move my screens around here a little bit so I can share this again. And Jennifer, while I'm sharing this, was there anything that I missed?
Well, I just wanted to tell students who are with us today that if you're thinking about coming to Rowan, today is the last day that you would be considered for a merit scholarship. So if you think that you might want to come to Rowan and you have your Common App set up, go ahead and click Rowan and send it. You don't need all your supporting documentation today, but if they get your application today, you'll be considered for a merit scholarship. And when I say merit, it's not just based on your GPA. It's we have a holistic review of the application. So go ahead.
Thank you.
Click.
Thank you so much for, yes, click that send button on your Common App. I don't think that we have any supplemental essays for our regular application.
And if you can't make it today, know that our application date is March 1st, and Rowan has a lot of other scholarships. We have the Rowan Foundation that offers scholarships to students throughout their academic career. So if you can't get it today, it's okay. You're still going to be considered, but the merit scholarship piece is really worth trying to get to.
So I think everybody that's joined us today can get a real clear idea of our physics department and how close-knit it is, the wonderful research opportunities that our students have, the relationships that they've built, the success that they are going on to in their careers and graduate programs. So if you have any other questions, please get in touch with us. We love to hear from prospective students. I have Dr. Klassen's email here listed. You might want to grab your phone, just take a quick picture. If you want to learn more, go to rowan.edu/physics. One of the programs that we have with the biophysics major is the 3+4 med programs. So I've also listed the health advising at rowan.edu email. Of course, our admissions office. Please contact them with any questions, any details on housing, on tuition, any other more university-wide questions that you may have. Oops, I'm going too fast and I did it again. Sorry, it's been a long day. And I have the Office of Financial Aid on there too. So what else do I have here? And so this is the end of our session today. I want to thank everybody that's joined us. On behalf of everybody on our panel, we wish you a wonderful college search. This is such an exciting time for high school students and their parents. And we hope to see you on campus soon. Bye-bye. Thank you so much
for joining us.
Bye, everyone. Have a great day. Stay safe.
Take care.
Stay safe.